Hello everybody, welcome to the AP Pre-Calculus video for 1.5, day 3, final topic, just talking about inequalities here. I am Coach Meidenbauer. Before you exit this video, make sure you like and subscribe. All right, so here we go. We're talking about inequalities here. We're going to kind of sort of get into it, what inequality means. And that's what I mean, this little reminder right up here. If we have f of x referring to the y values, it's the height. If we ever have f of x is bigger than 0, that means we're above the x-axis. If we have f of x is less than 0, that means we are below. Okay, a couple little reminders we should be on that. First examples look really kind of like a warm-up. We have this function f of x right here, only have the graph. We don't have anything else that relates to it. Where does f of x equal 0? So you can look right here and find out where our zeros are. Looks like that we equal 0 at x equals -3, -1, and 3. Okay. Next one, B. Where is f of x bigger than 0? So when is the y larger than 0? So you're looking right here. And I'll kind of shade. Looks like I'm larger than 0 from here to here. And from here to here. Okay, so what are those values? And also, we can't equal 0 either. So we're going to write this in interval notation. If you were to remind you for interval notation. If we have parentheses, those are parentheses, by the way. We use that for the non-equaling ones. If we use brackets, we use those for the inequalities where we have those lines underneath, which means we can equal. Okay? Interval notation. Here we go. So looks like I can be between -3 and -1. So I'm going to go between -3 and -1. These are the open parentheses. And we're going to be from 3 forever. So we're going to go from 3 to infinity. By the way, infinity and negative infinity always have the open brackets. Always. You can never equal negative or positive infinity. Take note, a little different than probably other classes. AP, College Board, they want you to write the word and, or you can list it with commas or whatever. We don't use unions with that. So just take note of that. You won't get anything wrong. It's just what you're going to see. I want you to be more familiar with seeing the and. Okay. So that's when we are bigger than 0. Okay. Now, where is f of x less than or equal to 0? So this is the one where we're using the hard brackets, and I'm going to shade now in the blue. Okay, so when am I less than 0? I'm less than 0 here. And here. So what are those intervals? They're going to be from negative infinity, which I said is always, oh boy. Oh boy. Sorry, I'd say it's easier if I just zoom in here. From negative infinity until -3, and I'm going to include it. And from -1 to 3. And that's our video. Kidding. There's more. Okay, so now what if I don't have a graph? All right, so what I do. You have to solve for it. Make sure that we have linear factors, and we just make a sign chart. No big deal. All we're going to do when we make our sign chart is take this f of x graph, and we're going to condense it into one number line. It'll be super easy. All right, we got this. We got this. And it says test each values. I'll talk about how to test each values. I'm also going to let you know that we're going to use our ideas of factors if they're bouncing, if they're cutting, if they're flattening. We're going to use a whole shebang here, okay? So whenever we solve nonlinear inequalities, you make sure that the f of x value is equal to 0. We want 0 on one side, otherwise we can't do any type of sign analysis as it's known. So for our example here at 3, we do have a 0, so it's fantastic. And then really there should be like a step like 1a. It should be factor and if need be, okay? We do not need a factor here. Everything is factored form for us. They're all factors, happen to be linear factors, which is super nice. And we're going to test values on a sign chart. Okay, so I'll show you what that all looks like here. So that we have x equals 3, we have x equals -1, and we have x equals -4. Those are our 3 zeros we get. If you notice here, these are all cuts. So cut, cut, and cut. I'll tell you why that's important in just a moment. Okay, we're going to make our number chart. Just any horizontal line, draw your favorite horizontal line that you want. And now I'm going to label each of these points on here. Now, since I can't equal 0, I'm going to use open circles. That's going to help me. It's my sign chart. It's going to help me know if I'm going to equal it or not. So I'm going to use an open circle here. There are 3 of these zeros. And what are they in numerical order? -4, -1, and 3. Okay. So now I need to know what my signs are. So there's really 2 thoughts. The one is to plug in numbers in each interval and see if it's positive or negative. Because if a number between -1 and 3 is positive, then everything between -1 and 3 is positive because it doesn't cross the x-axis again. Okay, so I'm going to pick a number. I'm going to just start on I always start on the right-hand side. Okay, I'm going to start over here on this side right here. Okay, so sorry, I didn't really want to circle that. I just wanted to tell you where it's starting. So I'm going to start over there. So I'm going to pick a number, I don't know, like if I have a 3, a number that's bigger than that is a 4. So I'm going to pick 4. Look at my signs when I pick a 4. So I pick a 4, plug a 4 into the first factor, I'm going to get a +1. I only care about signs, so I get a positive. If I plug a 4 into the middle one, I'm going to get a 5, which is also positive. And I'm going to get an 8, which is also positive. Now those are positive times positive times positive, which gives me a positive value. So in that interval from 3 to infinity, everything is going to be positive above the x-axis. And you can go through and keep picking. Like for the next interval, you can always pick a number between -1 and 3. I'll just pick 0 because 0 is usually the easiest one to pick. If I pick a 0, on my first factor there, I'm going to get 0 minus 3, which is negative. And then 0 plus 1 is going to be positive. And then 0 plus 4 is positive. So you get negative times positive, which is negative, times positive, which is still negative. So this is going to be a minus. Okay. You can keep going, but I'm going to tell you right now, I have a little, it's not a shortcut. It's a joke. You don't even know it yet. It's not really a shortcut, but it's just using the knowledge that we have. Well, if we have all cuts, get it now. If we have all cuts at 3, -1, and -4, that means it goes through the x-axis. If the polynomial goes through the x-axis, that means we change signs. So at 3, we cut, we change signs. At -1, we cut, we change signs. So that sign is going to turn into a positive. At -4, we cut, we change signs. So that's going to turn into a negative. Super awesome. Now for my inequality here, I'm looking for numbers that are bigger than 0. So I'm looking for positive numbers. So I'm going to shade my positives. Okay. So that's what I'm looking at. So my answer here, looking for positive numbers, is going to be from -4 to -1 and 3 to infinity. They should be parentheses. I guess I'm not really good at drawing parentheses on the left side. Okay. I'm going to erase that because I'm sure someone will be wondering, wait, what is that? Because they have me on mute. Why would you mute me? Don't answer that. Okay. Boom. That's it. Now, one more little thing. One more kind of sort of shortcut. If I look at the end behavior on the right side, if you notice, this is a positive inequality on the left-hand side of the inequality. It's positive function, so the right end behavior is going to be positive. So I didn't even need to pick a number the whole time. I could have just saw like that, oh, right end behavior is positive. It's an odd. If I add all those up, it's odd function. So the end behavior is going to be different. So it's going to be positive on the right, negative on the left. Could have did that right off the bat. All right, here's our next one, last one actually. Super nice. If you want to kind of go through and try this one on your own this is a little bit of a difference here, but if you want to kind of try number 4 on your own because of number 3, go ahead. I'd advise you hit pause, try it on your own. All right, well, if you tried it on your own, welcome back. Here we go. Let's go ahead and do this thing. We're going to get x equals -2. We're going to get x equals 5. Those are my 2 roots that I have here that I'm going to draw on my handy-dandy number line. Okay, at -2, I'm going to write a B, which stands for bounce. And at 5, I have a cut because -2 has a multiplicity of 2, and 5 has a multiplicity of 1. So I can equal here, by the way. So I'm going to put solid dots because I can equal. Solid dot at -2. Solid dot at 5. Okay. Now let's do a little bit of sign analysis here. You can go ahead and pick a number if you want. I'm not going to be judging you. Okay. If you want to pick a number bigger than 5, great. Go ahead and do that. Plug everything in. But I do know that this is a positive right end behavior. So I know I'm up here. This is where the curve sketching can really help you out here. We have a positive end behavior. And we're going to cut at 5. So we're going to change signs. And then we are going to not change signs at -2 because that's a bounce. The polynomial is tangent to the x-axis at -2. It's going to bounce. Boom. What kind of numbers am I looking for? What am I shading? Well, these are going to be negative numbers. Okay, so I'm going to be shading here. I'm going to be shading here. Okay, so I'm going to go from -infinity to -2 and include it, and -2 to 5. I know what you're thinking. Coach, why did you just do that? Is it negative part of the answer? Totally. So this is really going to tell you that the answer is actually -infinity to 5. Okay. Because since we include -2 in both of those, if you want to just write that for giggles, that's not incorrect. But we're going to be looking for the answer -infinity to 5. That would be the one that we want to look at. All right, and that finishes up our solving nonlinear inequalities for polynomials. Finally, 1.5 is now over. Like and subscribe.